Welcome to Understand the Math. In this video, we'll look at something that can instantly tell you what type of solution a quadratic equation has without solving it. It's called the discriminant. And once you learn how it works, you'll be able to tell what type of solutions the equation has. Let's start by learning about what the discriminant is. The discriminant of a quadratic equation is just a number that you calculate, and it tells you how many solutions there are and what type of solutions they are. We typically write a quadratic equation as ax squared plus bx plus c is equal to 0, and the discriminant, represented by delta, is equal to b squared minus 4ac. If the discriminant, or delta, is greater than 0, then you're going to have two distinct real solutions, and they can either be rational or irrational. This means that the graph of the quadratic equation, which is just a parabola, will cross the x-axis at two different points. If your discriminant is equal to 0, then there is going to be one repeated real solution, and that solution is going to be a rational solution. This means that the parabola will touch the x-axis at only one point. And then lastly, if the discriminant is less than 0, you're going to get two complex or imaginary solutions. Because there are no real solutions, you can see in the graph on the right that our parabola never touches the x-axis. Let's now look at some examples. The first examples that we're going to look at are when the discriminant is greater than 0. Just as I mentioned on the previous page, when our discriminant is greater than 0, we're going to get two distinct real solutions. They can be rational or irrational. The solutions are going to be rational when the discriminant is equal to a perfect square. And in this case, we can solve the quadratic equation by factoring, using the quadratic formula, or using the square root property. I have videos on all of these factoring techniques. When you get two distinct solutions that are irrational, the discriminant is not equal to a perfect square. And in that case, you're going to solve the quadratic equation by using the quadratic formula. Let's now look at examples of both of these cases. Our first example is going to be where the discriminant is positive and it's a perfect square. Let's go ahead and let's start by calculating that. Our discriminant is going to be represented by delta, and it's equal to b squared minus 4ac. B is the constant that multiplies the x term, and in this case, it's equal to -1, and we're going to square that. And then we're going to subtract 4 times a. A is the constant that multiplies the x squared, and that's 1. And then our c is our constant all by itself, and that's -6. Let's go ahead and simplify this. 1 squared is 1, and then we have a -4 times a -6 gives us a +24. And that's equal to 25. 25 is a perfect square because we can write it as 5 squared. That means that we are going to get two distinct rational solutions. Let's go ahead and find these solutions. Up above, I mentioned that we can find these solutions by factoring our equation using the quadratic formula or using the square root property. I'm going to solve this equation using factoring, and I'm going to use trial and error. And the reason that I'm going to do that is our equation x squared minus x minus 6 is equal to 0 has a 1 in front of the x squared. And whenever that happens, trial and error is usually the best way to solve it. We're going to factor this as x minus 2 and x plus 3. And remember, what you're trying to do when you factor by trial and error is you're going to find two numbers that multiply to get -6, and those two numbers have to add up to be -1. And in our case, it's equal to -2 and 3. We can then set each of these terms equal to 0. So we have x minus 2 equal to 0, and we have x plus 3 equal to 0. So our solutions are x is equal to 2 and x is equal to minus 3. Let's go ahead and let's highlight those. Just to recap, the discriminant was positive, it was a perfect square, and we ended up with 2 real solutions. Let's now look at our next example. This is an example where we are going to have 2 irrational solutions. We'll begin this one just like we did example 1, and we're going to calculate the discriminant. Our discriminant is equal to b squared minus 4ac, and that's going to be a minus 4 quantity squared minus 4 times 1 times 1. Let's go ahead and let's simplify this. This is 16 minus 4, which is equal to 12. Notice that 12 is not equal to some whole number squared. So that means that it is not a perfect square. And whenever that happens, we want to solve our quadratic equation using the quadratic formula. I'm going to go ahead and I'm going to write down that quadratic formula. It's x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. I want to point something out before we go on further. Notice that what is inside our square root is our discriminant. Now let's find out what x is. Our x is equal to negative b, so that's minus 4, plus or minus the square root, and we've already figured out what b squared minus 4ac is. It's equal to 12, so we can just go ahead and plug that in. So that's 12, all divided by 2 times a, which is 1. Now we have to simplify. This is 4 plus or minus the square root. Let's go ahead and let's write 12 as 4 times 3, and we're going to divide by 2. So this gives us 2 plus or minus 2 root 3, all divided by 2. And our 2's are going to cancel nicely. We're going to end up with x is equal to 1 plus root 3, and then 1 minus root 3. And let's highlight these answers. We ended up with 2 solutions. They are real solutions, and they are also irrational solutions. And that's because our discriminant was positive, but not a perfect square. Let's now look at our next example. This example is where the discriminant is equal to 0. Just like we talked about previously, when the discriminant is equal to 0, we're going to get one repeated real solution, and it's going to be a rational solution. We're going to solve it by factoring, and we're going to factor it by noticing that the equation is a perfect square trinomial, and we can factor it as the square of a binomial. Let's look at this example and see how that works. Our discriminant, again, is equal to b squared minus 4ac. I know we've written that down a lot, but if you write it down every time, you'll easily memorize it. Our b is equal to 8, so we have 8 squared minus 4. Our a is 1, and then our c is 16. This is going to give us 64 minus another 64, and it's equal to 0. This means that we can factor our equation as x squared plus 8x plus 16 as the square of a binomial. That means that we're just going to take the square root of this term and the square root of that term. I have a video on perfect square trinomials if you want to review that concept. This gives us x plus 4 quantity squared. We're going to set that equal to 0. And this tells us that our solution is x is equal to minus 4 and minus 4. There are 2 of them because of the squared term right there. Let's go ahead and let's highlight this. And just to recap, our discriminant was equal to 0, and we ended up with 2 repeated real solutions that were rational. Let's now look at our last example. Our last example is when our discriminant is less than 0. When this happens, we're going to get two complex, or you can call them imaginary, solutions. The way that you solve an equation when the discriminant is less than 0 is you're going to use the quadratic formula. And let's go ahead and let's do that with this example. We'll start by calculating the discriminant. Delta is equal to b squared minus 4ac is equal to minus 2 quantity squared minus 4 times a, which is 1, and then our c is 5. And this gives us a 4 minus 20, which is minus 16, and it's less than 0. So we know we need to use the quadratic formula, and we're going to get complex solutions. Let's again write down our quadratic formula. X is equal to negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. And then again, let's just remind ourselves that what is inside the square root is the discriminant, and we found that that was equal to minus 16. That way we don't have to calculate it again. So here we go. X is equal to negative b, so that's minus a negative 2. Watch out with those negatives. Plus or minus the square root, and we're going to plug in minus 16, and then we're going to divide this all by 2 times a, which is 1. Let's now simplify this. This is 2 plus or minus, and what we're going to do here is we're going to split up the square root of minus 16, and we're going to write it as a 16 times a minus 1, and then in the denominator we have a 2. This gives us x is equal to 2 plus or minus the square root of 16 is 4, and then the square root of negative 1 is equal to I. Let me go ahead and let me write that up here, just in case you need to review that. Square root of negative 1 is equal to I. So we have 4 times I, and then we have our denominator of 2, and this gives us, dividing each term by 2, we have 1 plus or minus 2i. Our final solution is then x is equal to 1 plus 2i and 1 minus 2i. And you can see that when our discriminant was less than 0, we ended up with two complex or imaginary solutions. And that's it. Knowing the discriminant saves you time and helps you choose the best method for solving a quadratic equation. And it also helps you predict what the graph of the equation is going to look like.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.